Brad Williams, XL Prime. Covariance. The correlation and covariance tools can both be used in the same settings when you have n different measurement variables observed on a set of individuals. The correlation and covariance tools each give an output table, a matrix, that shows the correlation coefficient or covariance, respectively, between each pair of measurement variables. The difference is that the correlation coefficients are scaled to lie between -1 and 1. Corresponding covariances are not scaled. Both the correlation coefficient and the covariance are measurements of the extent to which two variables vary together. The covariance tool computes the value of the worksheet function covariance.p for each pair of measurement variables. Direct use of covariance p rather than the covariance tool is an unreasonable alternative when there are only two measurement variables. That is, the entry on the diagonal of the covariance tool's output table in row 1, column in row I, column I, is the covariance of the ith measurement variable with itself. This is just the population variance for that variable as calculated by the worksheet function var p. You can use the covariance tool to examine each pair of measurement variables to determine whether the two measurement variables tend to move together. That is, whether large values of one variable tend to be associated with large values of the other, positive covariance. Whether small values of one variable tend to be associated with large values of the other, negative covariance, or whether values of both variables tend to be unrelated, covariance near zero. Similar to correlation, we're just using covariance. Can do this ourselves using the covariance function with indirect, exactly as we did with correlation, or we can build our own. And as you can see, the higher the number, the higher the covariance, and vice versa. What we do is build covariance table. You can see in some instances, test 5 and test 3, they have negative covariance, that is high. And then on the other hand, test 1 is 14. Is that relative? It's really hard to say. You have to use other tools to determine what level of importance this is. A test 5 and test 5, well, you can see the covariance is the same. Well, they're testing one another, whereas test 1 and test 2 is 14, and that's relative to the basis, whatever the number is. So you have to know your scale, you have to know your tests. Build this table, grab a range. Clearly, we don't need names. We'll go back up here, data analysis, covariance. Our input range will be test 1 all the way down to J or F14. Group by rows, labels in rows, output range. Click this, hit an output, and hit OK. There we go. And this should be close. Again, we're using random numbers here. That's how simple it is in terms of reading it. If you're doing the test, you should be a little more familiar with the inputs and the output, but that's a covariance. I'm going to delete this. If you want to build this, what you'll do is just enter this data here yourself. Just type it in, then test 1. Then just enter this information here and then copy down and copy right.
Brad Williams, XL Prime. Thanks for watching.